Alright, these are special factoring special products. So this is a little bit different. Now, you could factor this way. You could put the negative 81 on top, and since there's no x's, there's nothing in the middle, see a number in the middle, what you do is you just put a 0 on the bottom. You could do it like that. That would leave you with, looks like a negative 9 and a 9. Negative 9 times 9 is negative 81. 0 on the bottom. You add those, get 0. Again, the 0 came from because there's 0 x's. And then your answer is x minus 9, x plus 9. That is a way of doing it. But there's a shortcut. And here's the shortcut. If you look at these two, this is called a difference of squares. A difference of squares. Why is it called a difference of squares? That right there is a difference. This right here is x squared. That's a square value. 81 is 9 squared. See how that's a difference or a subtraction of two squares? And basically, how you factor it is you call this a and this b. And your answer is always going to be, a plus b and a minus b. A, b. A is x, b is 9. So, as you can tell, a is x, so that's going to be x plus b is 9 and x minus 9. Again, a plus b, a minus b. Now, these look different. The reason? Because you switch flop. It doesn't matter what order they're in. When you multiply, it could be either order. Again, this could be a minus b and a plus b. It's just that one's minus, one's plus. The key is they're both squares, difference of squares. You could jump to a quick answer. Here, it makes more sense with this next problem. When you look at this next problem here, what you do is you look at each of these, and you look at, these are difference of two squares. It's a lot easier. And what you notice is, for the first one, you notice to get 9, that would be 3 squared. And to get x to the fourth, that's x squared. So, 3x squared times 3x squared is 9x to the fourth. And when you look at this one, what squared gives you 25? That'd be 5. What squared gives you y squared? That'd be y. So, the first piece, 3x squared is this. 5y squared is this. This is your a, this is your b. According to the formula right down here, a plus b, a minus b, our answer will simply be a, which is 3x squared, b, which is, put a plus because of plus, b is 5y, so a plus b, and then we also have a minus b. It's actually really cool, real easy, once you can spot the two squares. It's called a difference of squares. Now the last one is not a difference of squares. Now you could multiply front and back, but that gets a really big number. This one's a little bit different. Now what you notice here, do you notice that both those are squared? This is 3x squared, and this is 5 squared. If you notice, those are both squared, okay? And then what you do is you go, okay, just like here, you call this a, this b. If you multiply those two, if you take 3x times 5, you multiply these two, what you get here is 15x. If this is half of that, then there's a shortcut. Again, or you could think of it as if you double this and you get this, there's a shortcut. So if this number is half of the middle number, you can do a shortcut. And here's what the shortcut is. It's simply going to be this plus this squared. Okay, so let me describe that a little bit better. Your answer will always be a plus b squared, which is a plus b times a plus b. Now when you square things, it means multiply by itself, but we usually write it like this. If these two terms, when you multiply them, if that number is half of that, then you could jump to this. Now if this number is not half of that, you basically got to do the long factoring method. This times this. Actually, let me stop and restate that. If these are both squareds, like this, and it doesn't equal half that, it's not factorable. It just always works out like that. But if they're not both squareds, then you multiply the front and back. So the key is looking for two squared values. Here we have squared values and squared values. This is all based upon squared values.